Welcome back, guys. In this session, we are just trying to solve sheet 4 questions. Okay, sheet 4 questions starting on question 4. Okay, so there we have questions about converting angles. Okay, from radians to degrees and degrees to radians. Okay, so the first one there is convert 240. Okay, from angles into radians. Okay, so how do you convert from angles into radians? Okay, so let me just get a plain paper, my board here. Okay, let me get my pen. Okay, so where is it now? Yeah, where are my questions? Where are my questions? Okay, okay, so these are our questions now. Let's start to convert 240 to radians. Okay, so the conversion factor there, we know that 240 degrees, we are converting it to what? To radians, right? So what did we say the formula is when you're converting from degrees to radians? Okay, so from degrees to radians, we said the angle in radians is simply equals to what? Equals to the angle that you've been given in degrees, okay, then multiplied by pi over 1/8. This was the formula that we used, right? Okay, so it means that 240 in radians will just be equals to 240. Then we have multiplied by pi over 1/8, like that. Okay, so when I multiply there, what do I get? I get a 240 pi divided by 180. So here I can simplify it by simply saying the 0 and the 0 go. Then I'll remain with the 24 here. So we know that a 6 can go into 24 4 times. So we have 4 pi, then a 6 can go into the 18 3 times. Okay, so this is our angle in radians. Okay, so that 240 that we had in radians is the same as 4 pi over 3 there. Okay, so I'll just solve one example because this is very simple. Okay, well, let me solve another one just for the sake of someone who has not understood. Okay, so convert, let me use that negative one there. Okay, convert negative 250 to radians. Okay, so whenever you see a negative angle, so they have negative 250 like that as my angle given. So whenever you see a negative angle, it means we can find the positive angle of this. So how do you do that? You just simply say 360 minus that 250. Okay, so when you do that, what do you get? Okay, what did you get? So is it 110 or something? Yes, okay. So 360 minus 250 is simply 110 degrees. Okay, and then now we are taking this 110 degrees into radians. So we'll say our angle in radians will just be equals to our angle in degrees multiplied by pi over 108. Okay, so it's equals to 110 pi over 180. And this will just be equals to what? Cancel 0, cancel 0. We have 11 over 8 pi. Okay, so this is our angle 110 in radians, just that. Okay, then let's go to converting from radians to degrees. Okay, so I'll get the first one there, which is pi over 3. So A, by saying pi over 3. So if I want to find my angle in degrees, I say my angle in radians multiplied by 180 over pi. So we are getting now the opposite there, right? So it means my pi over 3 multiplied by 180 over pi. So the pi and the pi will cancel. We'll remain with 180 divided by 3, which is what? 3 into 18 is 6. 3 into 0 is 60 degrees. Okay, so that pi over 3 there is the same as 60 degrees. Okay, let me solve one more from there. Which one looks hard there? Okay, I have negative 3 pi minus 4. I want to change it into negative 3 pi over what? Over 4. I want to change it into degrees. Okay, so I first have to find the positive value of this, which is just 2 pi over the same angle. Okay, so when I subtract there, I'll get what? 4 there. I'll get 8 pi minus 3 pi, which will just give me what? 5 pi over 4 as my angle. So now I'm converting this guy 2 degrees. Okay, so degrees is equals to the angle in radians, which is 5 pi over 4, multiplied by 180 over pi. Okay, so you can see that the pi is going to cancel there. So this pi will cancel with that pi. Okay, that pi and that pi will cancel. Then I have 5 multiplied by 180. Then I'm dividing everything by 4. Okay, so what do you get when you do that? So 5 multiplied by 180, then divided by 4. I'm going to get 225 degrees. Okay, so that's that. That's how you solve question 4 and 5. Then I'll move on to question 6. Okay, so question 6, now they are saying evaluate the following without using a calculator. Okay, evaluate the following without using a calculator. So this type of questions, that's where you need to know those special angles, guys. Okay, you have to know those special angles, because if they give you an angle, you won't have a calculator in the exam. Okay, so let's start from the first one. So the first one, we have to calculate what sine 240 is. Okay, calculate what sine 240 is. So we have to reduce, or we have to change this angle to a special angle. Okay, so how do you do that? That's the main thing that we have to know. All right, so this angle here is 240, right? Okay, and we know that 240 is in which quadrant? If I draw my quadrants like that. Okay, so this is my 0, that is my 90, that is my 180, and this is my 270, right? Okay, so this 240, it's somewhere here, right? And you know that in this quadrant, sine is negative. Remember, our all students take co, right? So sine in this third quadrant, where the angle at 270 is, it's negative. Okay, and how do we find the reference angle here? We say we just do 180 plus that reference angle, right? I'll have the given angle plus 180 gives you the reference angle. So in this case, our reference angle is 240. Okay, so let me write the formula. So the reference angle is equals to 180 plus the given angle. Okay, so the given angle is what we mostly use. The reference angle is what we mostly use. So meaning this 240 there is our reference angle. Then it's equals to 180. Then I want to find this angle in either this quadrant. Okay, so plus that angle. I'm going to say my angle is just what? 240 minus 180. Okay, so when you do 240 minus 180, what do you get, guys? Okay, 240 minus 180, you get the angle 60. Okay, and we know the value of sine 60 because sine 60 is a special angle. Okay, that's the reason why we are doing those special angles. If you didn't watch the special angles video, go and watch, right? Okay, so it means this sine 240 is the same as sine 60. Okay, the sine 240 is the same as the sine 60 there. Okay, so okay, so remember that this sine 40, its value has to be negative. Why? Because it's in the third quadrant. Okay, so it means here I'll write minus, then sine 60 there. Okay, even there I should include a minus because this value has to give me a negative now. Okay, from there we can find what that is. Okay, so we know that sine 60 is just simply what, guys? It's simply the square root of 3 over 2. Okay, so you have to swatter these guys. You have to memorize those special angles. Okay, so it means this sine 240 is just minus 3 over 2. If you punch it on your calculator, you see that it will give you the exact value. But here, I have not used the calculator. I just used the concept of the special angle there. Okay, so if you didn't get it here, let me do another example. So let's say we have B there. And B, what do we have? We have cos 300, right? Okay, so cos 300, okay, will be equals to what? So cos 300, I'll draw my quadrants, right? I know that this is 90, this is 0, that is 180 there. Okay, this is 270 there. Okay, 270. And then I know that this 300 there is within which range? Okay, so this is 0, we can also put this is the 300 as keys. So 0, 90, 180, 270, 300 as keys. So the 300 is somewhere here, right? Okay, and we know that our course in this area is what? In this quadrant, it's positive because all students take So the cos here is positive, right? Okay, so we have to find the reference angle, the given angle that they used to come up with this 300. So in this fourth quadrant, we know that the reference angle is found by subtracting 360 minus the given angle. So we're interested in this given angle. So the reference angle is what you have in the equation. So 300, okay, is equals to 360 minus that theta. So that theta will just be 360 minus 300. Okay, so it means the reference angle there just equals what? 60 again. Okay, so what is cos 60? Okay, what is cos 60? You have to know the special angle, guys. Okay, so cos 60 we know it's just half. So it means this guy here will be equal to cos 60, which is the same as 1/2. Okay, so that's that. So that's basically how you are going to be going about those quotients. Okay, so let me solve another one for 4 degrees, then I can go to the radians. Okay, so I should get which one? Okay, let me get SME there. Let's solve E. So E, okay, is sec minus 60, right? So remember when I was talking about odd trigonometric functions and even trigonometric functions, we said the only ones that are even are cos and sec. Okay, it means if I have a sec there and a negative angle, it's the same as the sec with that same positive angle like that. Okay, because what this negative angle means just simply means subtract this from 360. Okay, so which is the same as sec 300 here when I subtract from 360, and it should be equal to sec 60 there. Okay, so we know that sec is just what? 1 over cos, right? So 1 over cos 300 should be equals to 1 over cos 60. Okay, that's what we have there. And then we know that 1 over, and we know the value of cos 60, right? Cos 60 is half, so we put half there. So it means we're dividing 1 by half. I think it's what? 2. Your answer is just 2. Okay, your answer there would just be 2. Okay, so sec 60 is the same as 2. Okay, so here you can now put back the original equation that we are given, which is sec minus 60. Okay, so sec minus 60 is the same as the 2. Okay, so let me what do I want to do here? Okay, I want to move to the next question, but before that, just a minute. Okay, of course. Okay, so that's how you solve that. And then which one can I solve here? Okay, so let me solve for tan and take what there. Okay, so let's solve F. F there, we have got 120. Okay, so got 120 degrees. Okay, we know that cot is just the opposite of tan, right? Okay, so if I had to write this to just be 1 over tan 120. Okay, but do we know what value of tan 120 is? No, so we have to get a special angle. We go on our graph. Okay, that is 90. This is 0, stroke 360. This is 270 there. Then that is 180. Okay, so this number 120 is between 90 and 180, right? And we know that tan here is negative, so we must get a negative answer there. So all students take go. So we are in this quadrant here. We want to find the given angle in that quadrant such that we have 120. So the reference angle is just equals to here. The reference angle is equals to what? 180. Okay, minus the given angle. So the one that we are given in the equation is what we are calling as our reference angle. So 120 minus, is equals to 180 minus angle. So let's find that angle. So that angle will just be, angle is equals to 120 minus, 180 minus 120, which will just be what? 60, right? Okay, so the angle there is 60 in that quadrant there, but we know that tan has to be negative in that quadrant. Okay, so if I could clean some of this down there so that I continue, we'll have something like this. Okay, down there. Okay, so got 120 is equals to 1 over tan 120, which is also equals to 1 over, okay, minus tan, then the special one. Okay, why are we putting a negative? Because tan in this quadrant here is negative. Okay, so is equals to 1 over minus, what is tan 60? Okay, special angles, you have to know them. Okay, you have to know them by heart. Okay, so tan 60, we know it's just the root of 3, right? Okay, So we're going to put root of 3 there. Okay, and so got 120. It's the same as minus 1 over root of 3. Okay, good. Let's move. Okay, let's try to solve the ones that have radians there. Okay, so tan. Okay, I can see a tan there. 3 pi over 4. Okay, so is the 3 pi over 4 a special angle, guys? Okay, but the 3 pi over 4 is not a special angle because we know the special angles are pi over 4, which is 45, pi over 3, which is 60, then pi over 6, which is 30, right? Okay, so this is 30, 60, 45. Okay, and even put the 90, which is pi over 2. Okay, so this is the 90. And then what else do you have? You also have the 0. Okay, so these angles are special angles in terms of radians. But this 3 pi over 4 is not a special angle, right? So we want to find out in which quadrant is this in, okay? So to find out, we can first change it to degrees, okay? So changing to degrees, it will be that angle multiplied by 180 pi. Okay, so cancel pi, 3 multiplied by 180, okay? Then divided by 4, okay? It's simply going to give you what? Okay, so 3 multiplied by 180, and then it will give you 540. That 540 divided by 4 to give you 135, okay? So in degrees, that angle is just 135 degrees. So now we know where the quadrant that angle is in, right? So it's 135, and we know that 135 is just in the second quadrant, right? Okay, so 135 is just in the second quadrant, which will be equals to minus tan of the new angle that we're going to find here, because we know that here in the second quadrant, tan is negative. That's why I put a negative there. Okay, then we want to find the given angle there. So the reference angle is equals to, in the second quadrant, it's 180 minus the given angle, right? But now we're writing it in terms of radians. So the 180 is what? It's just pi. Pi minus the given angle. Then the reference angle we're given as the 3 over 4 is equals to pi minus 0, it's theta. So the theta will be equals to what? The pi minus 3 pi over 4, right? So 4 there, divided by 1. So this will be 4 pi minus 3 pi. Okay, it means our angle there will be what? Will just be pi over 4. And we know that pi over 4 is what? 45 degrees, right? Okay, so special angle 45 degrees. So tan 45 is what? If I can remember, it's 1. Okay, so tan 45 is 1. So here our pi over 4. And we know that pi over 4 is just 45. Okay, we can even write it like that. Then you say minus. Okay, so tan 45 is 1, positive 1. And then it's receiving a negative there because it's in the second quadrant, right? Okay, so the final answer will just be minus 1. Final answer will just be minus 1. Yeah, so that's how you solve those questions. So just practice more, solve more questions, and then you get the hang of it. All right. And then I'm off question 6. I go now to question 7, where we have trigonometric identities. Okay, so about identities, you have to know the identities of those common ones that we have, right? You have to know the identities of those common ones. So the common ones that we have, okay, we are going to use them to find what we do not know. So A there, I can see that on A, question number 7, on A, I have tan. No, I have what? I have sine. Okay, I have sine x is equals to tan x cos x. Okay, so the funny thing about proving identities is that you always have to select the part that looks more complicated, and then you simplify it to get the other one. Okay, so here I have the sine, and then there I have the tan cos. I have the tan cos x there. So meaning I'm going to choose this one because it looks more complicated than this, right? Okay, so I'm going to say tan x cos x is just equals to the left hand side. Okay, the left hand side is sine, right? But we know that this tan can be written as sine x over cos x, okay, multiplied by this cos outside there. Number 1 should be equals to the right hand side, right? Okay, so we can see that this cos is going to cancel with that and just remain with the sign there. Is equals to left hand side. Okay, and indeed the left hand side is the sin x again. Okay, sin x. So hence the proved you write like that. Okay, so this is a very simple one, but it's going to get done. All right. Okay, so let's go on B and try to prove the identity. So we have 1 over 1 plus sin x plus 1 over 1 minus sin x is equals to 2 cos x squared x. Okay, so we can see that this part here on the left is more complicated, right? So we're going to simplify this to obtain that. Okay, so let me write it there. I have 1 over 1 plus sin x plus 1 over 1 minus sin x. Okay, and then this is equals to what? They said it's equals to what? It's equals to 2 cos x squared x. Okay, so we are trying to prove that this guy here is equal to the right hand side, right? Okay, so what do we notice between these two? We can see that the denominator is there. They're just the difference of two squares, right? So to simply mean that, okay, let me not even say that. I'll just say common denominator. Let me not confuse anyone. Right hand side. Okay, common denominator is both of these things, right? You just write them there. And then the other one, 1 minus sin x. Then on top now, that's where there will be changes. So this guy divided into this guy, this will cancel. We just remain with this. So this multiplied by 1, you still have your 1 minus sin x like that. And then plus this will cancel with that. You have the 1 plus sin x there. And this equals to the right hand side. So on top there, we notice that minus sign and sign they'll cancel. And we just remain with 1 plus 1, which is a 2, right? Over. And then now down here, we notice that this is a difference of two squares. Okay, so it's just the same as 1 minus sin squared x. Okay, which is equal to right hand side. Okay, but we know that this identity here down is just a cos. Okay, from cos x, cos squared x plus sin squared x. We say this identity was equals to 1, right? So it means the cos squared x just equals to 1 minus sin x, sin squared x. Okay, so you can see that in that place, we're just going to put the cos x, right? Okay, so let me clean this part down here and then see what this will become. Okay, so this will become 2 over cos squared x is equals to right hand side. Remember on the right hand side, what do we have? We have a sec squared x, right? But we know that sec is just 1 divided by cos, right? So I can separate this reaction into 2 over 1 multiplied by 1 over cos x, cos squared x, like that, is equals to right hand side. Okay, and then here we see that 1 over cos is just sec, right? So it will be 2 multiplied by sec. Since the cos is squared here, also square the sec, then x is equals to right hand side. Okay, so it means 2 sec squared x is equals to right hand side. Okay, and so this is the hence proved. Okay, hence proved. We've proved that whatever we had on the left is equal to whatever we had on the right, right? Okay, let's go to another one, which is C, and see what it has for us. Okay, we have cos x plus tan x. So cos x plus tan x. Okay, cos x plus tan x is equals to sin x. Then in the bracket you have sec x plus cot x. Okay, sin x. And in the bracket you have sec x plus cot x. Okay, so between these two sides, which one looks more complicated? Okay, so you always prove the one that is more complicated, right? Okay, so I'll choose my right side. It looks like it has a lot of things. So I'll simplify this to get whatever I have on my left. So I have sin x, sec x, plus, okay, this is sec, plus cot x, okay, is equals to the left-hand side. Left-hand side here is that, right? Okay, so from here, what can we do with this thing? I see that from there, I can simply multiply the sign with whatever I have there. Okay, but before I multiply, let me change my sec x to 1 over cos x, right? Plus, then the cot, we know that it's just cos x over sin x. Okay, and this should be equals to right hand side. Then I distribute my sign there to be sin x over cos x, then plus sin x multiplied by cos x over sin x. Okay, is equals to right hand side there. So we see that this guy here, this is sine over cos, it will become tan x. And then here I can say that this sign is cancelled with that sign, so plus just remains the cos x there is equals to left hand side. Okay, so you can see that this is the same thing that we have on the left hand side there. We have cos x plus tan x, which is the same as tan x plus cos x. So we can even write it the way it is in the equation, plus tan x is equals to right hand side, hence proved. Okay, let's look for another one. We are on E. We just solve all of them anyway. So on E there, we have, of course, squared x on top. Cos squared x on top over 1 minus sin x, 1 minus sin x. Okay, and then is equals to 1 plus sin x is equals to 1 plus sin x. Okay, we can see that the left-hand side here looks more complicated. So we're going to prove that this is equals to that. Okay, but we know that whatever we have on top is the same as 1 sin x squared x, right? So you have to know the identities. Then minus 1 sin x down there should be equals to the right-hand side. Okay, I'm getting this from the identity of cos squared x plus sin squared x is equals to 1, which means my cos squared x is just equals to 1 minus sin x. And you can see that whatever we have in the numerator, there's just a difference of 2 squared. So I can also write whatever I have in my numerator as 1 minus sin x. Okay, and then I write 1 plus sin x. Okay, over 1 minus sin x is equals to the right hand side. Okay, so you can see that the 1 and the 1 minus sin x, 1 minus sin x to cancel. Then I'll just remain with this. Sin x is equals to the right hand side. Okay, and this is exactly what we wanted to find here. So hence proved. Okay, let's look at the last question on the identities. We have cos x, cos x over 1 plus. Okay, so cos x over 1 plus sin x. Okay, plus the opposite of that, 1 plus sin x over what now? Okay, over cos is equals to, and there we have 2 sec x, 2 sec x. Okay, so here we can see that this one is more complicated. So we'll look for the common denominator, which will just be cos 1 plus sin x. Okay, is equals to whatever we have there, which is the right hand side. Okay, so this 1 plus cos x divided into there, I'll just remain with the cos x there, right? So cos x multiplied by cos x to be cos squared x, right? Okay, cos squared x, then plus this cos divided to that, this will cancel to be this guy multiplied by that guy. So 1 multiplied by 1, 1 multiplied by sin x multiplied by 1, I have 2 sin x there. And then sin x multiplied by sin x to be plus sin squared x. Okay, so sin squared x and the cos squared x, you can group them together and they'll give you a 1. Okay, so cos squared x plus sin squared x, then plus 1 plus 2 sin x is equals to the right hand side there. Okay, of course, here it's been divided by the cos x. Then in the brackets, 1 plus sin x there. Okay, so that one becomes 1. So 1, the one that we obtain when we add these two there. Okay, let me change the one that we obtain when we add these two, because that's the identity there to give you 1, right? So 1 plus 1 is going to give me 2 plus 2 here in front, sin x over cos x, and then multiplying that by 1 plus sin x. Okay, then this should be equals to the right hand side. So from here now, what can you do? Okay, we can say that we can factorize the 2 on top there. Okay, so 2 1 plus sin x over, then down you have cos x, 1 plus sin x there. Okay, this should be equals to right hand side. So it means I can cancel the 1 plus sin x. I'll just remain with 2 over cos x, which should be equals to the right hand side. Okay, which should be equals to the right hand side there. Okay, now, and we know that that guy there can be separated to 1 over cos x is equals to right hand side. And you know that this guy is sec, right? So it will be 2 multiplied by sec. Okay, so sec x is equals to the right hand side. Hence proved. Okay, hence proved. Because we are looking for 2 sec x, right? That's what we had there. Yes, here. Okay, so from this we've gone all the way down here, and we have found our 2 sec x there. Okay, so have a blessed evening. I'll record another video for solving question 8 and then question 9 there.